Thank you. I present me. I'm Alexandre Lairan, developer at Paris. So you can find me. Let's start the talk. It is starting. Yeah. So my name is Alexandre. I'm working at Paris. I love everything about Ruby, about machine learning, and I'm a developer at Pledzi company. Pledzi company, it's a company who help marketers in their day-to-day task. So for this talk, we will not talk about TensorFlow because let's stay simple. So no TensorFlow, no Keras, and no anything like that. Just pure logic and some code in Crystal. I'm a member of Paris RB staff, so if you came to Paris, don't hesitate to come. So let's begin. What's an AI and what's an person research? Because there is some mistakes with both of them. So an AI is a program who can learn with data, and the person research is a program who have data and will treat the data, example a minimax or Dijkstra algorithm. We will see a minimax algorithm. So it's a simple one. It's just, example, you have a two-player game, in turn-based game, example, tic-tac-toe. And with the tic-tac-toe, you play a cross, then your opponent will play a circle, and you have to guess where is the best place to put my cross to win. So let's see how it works, how it can be a way to achieve winning. So you have your tic-tac-toe, and this is the current state. Each place you can put a cross, there is one node. Each node will have children. So in the first level, I will have nine nodes, and in the next level, I will have 8 nodes because I can't put some stuff on existing cross or existing circle. But why do we need to put some node somewhere? It's because we have to calculate where is the best place. And how can we achieve that is by have a current state. So this game is finished. Who winning? Who has the best score? So here I have some score at the leaf of my tree. So I have -10, for example. It's because I will lose. So I need to minimize my opponent possibilities. So I will choose minimum numbers on the second layer. Then I need myself to win, so I have to maximize the score I will get. So here the 3 will win because it's a maximum score. So this is a kind of operation research algorithm. The problem with this kind of algorithm is that they don't learn. They have some troubles if the meaning change, if the game have some rule who change in the I don't know why, but it can change. Your program will have to redo all the process. So we need something who can evolve. And when we talk about evolving, we can talk about living forms like cells, bacteria, etc., etc. And what is a big rule of living forms is genetic. Genetic, it's you have an initial population. So here we have some blue dots who can be cells. Then all of them will not survive because our environment is so cruel, and some of them will die. So the orange one will die. Now the survivor can reproduce together to have a new population. So let's do them reproduce. And in the reproduction process, there is one important thing is that some of them will mutate because with mutation we can explore possibilities. like in living forms. Mutation help to have all species in the planet, so it could be a good thing to to search about how I can have the best results. So they all mutate. The problem with this process is it takes a lot of time. In the world, it takes 3 billion years before have something very concrete, and our computer don't have this time to process the data. We need something more accurate quickly. One field have know how to do this is mathematics. Math have a good algorithm how they can help us in your task. So let's see how. I have some dots and a line. So to know if it's 5.5 x of that 5.5, if I can put a laser, no, I don't see. So I search where is 5.5 result, because I don't have a dot on this 5.5, and I want to know what's the result. Here it's a simple linear one, so it's 5.5 y. It's pretty simple, but our data in the real world doesn't like this, it's more like this. So where can I put my line? Should I go on the upper stage, on the down stage, or should I do a sinusoidal line? The two lines are too wrong. The blue one, it's underfitting. We are too general, so we don't have a great result. The green one, it's overfitting. It fits very well to the data, but the problem is if we have error on the data or if we have nose, it will fit to the nose. So it's not pretty good. It's not what we want. In the real world, we rarely want to search, to follow all points. We more want to classify things, like this is a cat, this is a dog, or this is a good prospect, this is not a good prospect. So we have to draw a line between our elements. Example here, the green one and the red one. We don't know our program, we don't know if it's a green or red, so we have to guess thanks an error function. So let's draw a line, and our line will try to fit to minimize the error function. So now it's a pretty easy one. We can split our data in only one line. The problem is our data, example, a user, you have a location, a name, an age, etc., etc. Each of them is one dimension. Here we have just a 2 dimension, but with 3, 4, or 100 dimension, it's not easy to just put a plane, an hyperplane, or something like that, and say in upper this line it's red, under it's green. And there is sometimes very rare behavior where we can split element. Example, the XOR problem. The XOR problem is it's a family of problem who respect a function f x and y equal if x and y equal together, x equal y, it's equal 0. But if it's different, it's equal to 1. So red dots are 1 and green dots are 0. We have to split them, and it's impossible. We cannot split with one line, with one curve, the two elements. So we have to vanish some of them. So let's remove the top of them and draw a line. Now we do the same with the bottom one. And when we make the two lines together, we can say when it's between the blue and the green, it's a red result. And when it's not between the blue and the green, let's say it's a green one. So this is cool, but this need a data scientist who have to play with the data, and we are not data scientists, we're more like developers, and we prefer something automatized Let's see how we can automatize this learning process. So in my path, I know how to do this. It's a neural network. So how a neural network works? It's with a chain of neuron. So we have a neuron here. It's a zoom on one neuron. So he have a sum of all these inputs, and it puts this sum on a sigma function. A sigma function, it's very many sigma. I use sigmoid, but there is really many other. So don't take apart and just say it's a sigma function. Oh, wait, restart from the beginning. Sorry. So, resume. So we have a neuron, and we need to have a neural network. So we have a list of neurons. How to resolve our previous problem? It's by using 5 neurons. So our 5 neurons are just 2 inputs, 1 output, and 2 intermediate layers. The intermediate layer help us to process the inputs and reduce the information to a simple one, whose the last neuron can process it. So it transforms it finds the function who is below the neural network. So you have all of the 4 possibilities. Then the 0, 0 related to a 0, the 1, 1 related to 0, the 0, 1 related to a 1, and the 1, 0 related to a 1. So what we can show is that in the middle we have always 1, 0 when the both is the same, but we will see when the input is different, middle neuron will be 1 and 1. Thanks to this, our neuron result will be 1, because it's just multiplication and addition. So the last one with result. So it's pretty simple. It's just multiplication and some all of the inputs and do a sigma function. We can simplify the process by using matrix. We can say one line, it's a vector, and all links between lines are matrix. And we can just multiply vector with matrix, and we have a better and quicker result than just multiply one thing by one thing. The processor will thank you. Let's begin to the real problem. I have a database who have a lot of numbers. Numbers named label 2, 1, 6, etc., etc. And my computer don't know how to tell me if this is a 6, this is a 1, and there is many of them. This dataset is provided by Yann Lequin, a French researcher in the machine learning world. It's 60,000 data, so you have a lot of things to process to your machine learning algorithm. So this is a 3, this is a 6, and our computer don't know how it works, how it is. Each image is just 28 times 28 pixels. So in a gray scale. Yep. Just and when we will process the data, we just do 1 and 1 each time and say it is a great one or not, and we will retry until we have a good result. So now let's build a neural network. So for the first layer, I just use 5 5 neurons just for image, but in reality it's 28 times 28 neuron, so it's much harder. So we have to put some data, some information on each lines. So example, we can say the first one here, it's like -1. The second, it's like 0.5, etc., etc. But it's a very long process and it's not accurate. So let's say we put a random number between -1 and 1 on each of them. It will simplify how we can deal with it. Let's talk about different algorithm and what you have to learn and what I have to learn too. There is a lot of neural network. Is this simple neural network, traditional one? You have convolutional networks who can help for this kind of problem. You have GAN networks and LSTM who has kind of neural network. You have a PageRank who help you to know if one node is more take than another, and you can say this is a one thanks this. KNN, you put all data inside a graph, and you link all of them who's the same. So all one elements will be linked with one element. All three elements will be with three elements, etc., etc. So it will help you to this. One thing you can some people you can follow to know more about machine learning. There is 3 Blue 1 Brown, a YouTuber who do some animation on mathematics and machine learning. Siraj Raval, who do some videos on machine learning and how your startup can do machine learning too. And Science for All, a French video maker who make a video for machine learning with English subtitles. So let's talk about code and how we can solve this kind of problem. Last year, someone come here to talk about Crystal, so I think it's okay to put some Crystal code. How can we translate a math function into a Crystal or Ruby function? It's simple. Example, the sum, it's just an injection, and we can reduce. So let's talk about code now. Yep. Where is my here? I put it in white. Sorry. Color. Preferences. Them. It's better. So we have some classes. We can I'll put the file here. So for the code, we just have to load all the data. So it's the 2 first lines here. We have we just have our MNIST loader data. So MNIST is the name of the data set. We load all of them into one structure to help us to just have one loop to process all the data. We have some entities like a builder to build some neural network to select them, build them, select them, and then process them. We have a nursery to make a different neural network to breed together. We have a mutator to mutate some of the neurons in a neural network, and we have a calculator who can say if a neuron is good or not. So our AI is an AI genetic because we talked about genetic before. There is many other way to learn with this kind of algorithm. You have gradient descent, who is better than genetic, but he needs more mathematics. So I prefer in this talk to talk about genetic one. So it takes more time, but he is simpler. And then just process the AI, and let's go deeper. So we have our AI here. So let's start. So we have an initial population. Here it's just a population, it's an array. We have an array of 1,000 elements with random value inside their nodes. Then we have our loop. So the loop we saw before for algorithm genetic. So we just do an evaluation process. When the evaluation process will sort them by their score, we stop if we have a good result and we say it's okay, let's stop and let's use the algorithm with the neural network. Then we select some of them. There is many ways to select elements. Poisson distribution, it's a good one, but here you can just take sample of some entities. Don't hesitate to take lowest results because they maybe have a big just some adjustment to do. Then they will be better than the best of the 51st, for example. Then we reproduce. We make them reproduce. So we just take all selected elements and make them breed in a nursery. And to finish with this algorithm, we just have a mutator who mutates the data. So we loop over and over, and at the end we have all our results. So this is an example of how the score change with this kind of algorithm. So we have the best score of each iteration each time. So we see we have sometimes very great results and sometimes an average one. So we wanted to have a great one, so we put a threshold at 0.1. So this one is at 0.1, so it's cool. So I take it. It's a problem because when we learn, we prefer an algorithm who do something like that. Something like that is more used in industry, and when you use TensorFlow or something like that, you will have something more like this kind of results. What is important is to have a good result at the end, and this is okay, but it's not perfect. We'll see. So let's go deeper in the code, because we just saw the algorithm, but we didn't see how the neural network process the information, and how we can say it's a 3, it's a 5, it's a 4, or something like that. So on neural network, it's a cost. So we have our neural network who have some result. He gives us a vector of results. He say for the 0 number, I'm not sure it's 1, so he say have 0.1% of accuracy for this one. For the second number, he can say, oh, I'm sure it's this one, so he say it's 1. So we have number between 0 and 1 who can tell us if it's this number or not. The problem is if he say it's a 5 and it's a 7, we have a problem because he have both of the results. So this cost function will test with our value and say I want a 5. You say it's a 5, okay, but you say also it's a 7. So I punish you. I will give you a high score. A very big score, but you want a smaller one, so you're punished. So for the score, it's called function. This is mediator. Don't see very well. Yeah. So for the neural network, he just call the function call. Simple one, who give you the vector of the last line. So how we process the last line, it's just multiplication of the matrix of line before him, time the vector of the line before, then he just had a bias. So it's a recursive one who we can we take the first layer, so the result one, then multiply by the lines between neurons, then restart until we are at the end at the last level. And the sigmoid function, it's just what I said to you, the sigma one. I choose the sigmoid one because it's a simple. It's just 1 over 1 plus exponential of minus x. The breeder. In the nursery, we just have a neural network, and we have to create a new one. So we have a father and a mother, and I just draw a card and say, oh, it's a mother, so I put the mother neuron in place. If it's the father one, I just put the father one, and we continue until the neuron is ready. So we have a free choice: father, mother, or average. Average is important, is to mix up elements to search new possibilities. So if the father is 1 and the mother is 0, the result will be 0, 5. So it's just that. Because already it's mutator. And the mutator will just go over and over all links and all nodes, and we'll just, in a probability case, we'll just add a number between 0 and 1, or -1 and 1. It's what we want. It's what you want. You choose which element you want. So that's it. What's the result of at the end? What we get when the algorithm is complete? You have number of all elements. So you have a minus 0.8, etc., etc. There is all nodes. So there's a lot of data, and all links. So this is a lot. And this is a neural network information inside under the hood. And to have all the graphic before, I just add a CSV file. It's CSV. I didn't see here. Score.csv. So this is a maximum node of each level. So this is what we get at the end. So thank you for listening to me, and if you have questions, don't hesitate to come talk with me.